The pressurization system of the 737 Next Generation airplane is similar to the pressurization systems of other Boeing airplanes.
The air conditioning packs supply pressurization for the cabin. The pressurization system has an outflow valve on the aft fuselage. The system also has two digital cabin pressure controllers in the forward equipment and electronics or E&E bay. The pressure controllers use the outflow valve to control the cabin altitude. One controller operates the pressurization system, and the other controller is a backup. The pressurization system also has safety components to keep the cabin pressure in limits. There are two safety relief valves for positive pressure and one negative pressure relief valve. If the differential pressure is greater than allowed, the safety relief valve opens to decrease the pressure in the cabin. The negative pressure relief valve opens when the external pressure is more than the cabin pressure. There are no cockpit indications when any of the safety relief valves operate. The controls and indicators for the pressurization system are on the forward overhead panel. You set the flight altitude of the planned flight with the flight altitude selector on the cabin pressure control panel. Set a cruise altitude of 39,000 feet. You set the elevation of the destination airport with the landing altitude selector. Set a destination elevation of 2,700 feet. You select the mode of the pressurization system with the pressurization mode selector. The selector has three positions: auto, alternate, and manual. The outflow valve position indicator shows the position of the outflow valve for all modes of the pressure controllers. The toggle switch controls the outflow valve when the pressure controllers are in manual mode. The switch is spring-loaded to the center position. Select Auto now. There are two indicators for the pressurization system on the cabin altitude panel. The cabin altitude differential pressure indicator shows the altitude of the cabin and the pressure differential. And the cabin rate of climb indicator shows the rate of climb of the cabin. The altitude horn cutout switch stops the cabin altitude warning horn. There are four lighted indicators that show the status of the pressurization system. To see how the pressurization system operates during a normal flight, you will now plan and complete a flight from home airport to vacation airport. During the pre-flight, you set the flight altitude on the cabin pressure control panel. Set the planned flight altitude from the dispatch sheet. Next, set the elevation for vacation airport. Last, make sure the pressurization mode is in auto and the auto fail light is extinguished. The pressurization system is now set for flight. You will now see how the pressure controller operates during a normal flight profile. While parked on the ground and during taxi with low engine thrust, the pressure controller fully opens the outflow valve to depressurize the airplane. During the takeoff roll, the pressure controller starts to close the outflow valve. The cabin pressurizes to an altitude of 200 feet below the airport elevation. The decrease in cabin altitude improves system performance and increases the comfort of the passengers during takeoff. While in flight, the pressure controller uses the outflow valve to control the cabin altitude. During climb, it keeps the cabin altitude proportional to the airplane altitude. When the airplane is at the planned cruise altitude, the pressure controller starts cruise mode. Although the airplane altitude may change a small amount, the cabin altitude remains constant during cruise. But if the differential pressure is at the maximum, the cabin altitude changes to keep the differential pressure at the correct limit. When the airplane descends from cruise altitude, the pressure controller commands a proportional cabin altitude descent to 300 feet below the planned landing elevation. By landing with the airplane pressurized, cabin altitude changes are minimized during approach. After landing, the outflow valve opens slowly to depressurize the airplane. After flight, there is no flight crew action for the pressurization system. Review the pressurization system controls and indicators. Touch any control or indicator for an explanation. Touch the green arrow to continue. There are several non-normal operations for the pressurization system. We start with the off-schedule descent. The off-schedule descent light illuminates if the airplane begins to descend before it reaches the flight altitude set in the controller. For example, if a flight aborts during climb and returns to the takeoff airport, the off-schedule descent light illuminates when the airplane starts to descend. The pressure controller begins a cabin altitude descent to 300 feet below the departure airport elevation. If you start to climb again, the off-schedule descent light extinguishes and the pressurization system continues to operate as usual. If during flight it becomes necessary to divert to an alternate airport. You must set the landing altitude to the elevation of the new airport. Set the elevation of the alternate airport. When you start to descend, the pressure controller decreases the cabin altitude to 300 feet below the new landing altitude in proportion to the airplane descent. If the pressure controllers fail, lights illuminate to tell you of the failure. If the primary pressure controller fails, the auto fail and alternate lights illuminate. Also, the master caution light and the air conditioning annunciator light illuminate. Press the master caution light now to extinguish the warning lights. The green alternate light shows that the alternate pressure controller now controls the pressurization system. The auto fail light shows that the primary controller has failed. To extinguish the auto fail light, select alternate on the mode selector now. The alternate pressure controller operates the same as the primary pressure controller. If the two pressure controllers fail, the auto fail light illuminates and the master caution and air conditioning annunciator lights illuminate. Press the master caution light to extinguish the warning lights. If the two pressure controllers do not operate, you must manually control the pressurization system. Select Manual on the mode selector now. When you select the manual mode, the manual light illuminates. To start, use the placard below the pressurization panel to find the correct cabin altitude for the current flight altitude. If your cruise altitude is 39,000 feet, read the correct cabin altitude of 8,000 feet. The outflow valve switch controls the outflow valve. You toggle the switch until the cabin altitude is at the value you read on the placard. In this example, the cabin altitude is above the necessary altitude. To decrease the cabin altitude, toggle the outflow valve to close. Since the pressure controllers do not operate, you must use the outflow valve switch to manually control the cabin altitude until landing. If the cabin altitude is greater than 10,000 feet, the cabin altitude warning horn operates. To stop the horn, press the altitude horn cutout switch. Although the cabin altitude is still greater than 10,000 feet, the horn stops. Pre-flight the cabin pressure control panel. The cabin pressure control panel is now set for flight. During climb, it becomes necessary to return to the departure airport. Choose the correct answer. During climb, if you begin a descent, the pressurization system will start a cabin descent to 300 feet below the elevation of the departure airport. Flight crew action is not necessary. Flight crew action is not necessary. After you complete your climb to the planned cruise altitude, it becomes necessary to divert to an alternate airport. Do the correct step. During cruise, it becomes necessary to divert to an alternate airport. Do the correct step. The pressurization system is now set for the alternate airport. During cruise, you see this condition. Do the correct step. The alternate pressure controller now controls the cabin altitude. The alternate controller operates the same as the primary controller. During cruise, you see this condition. Do the correct step. Because both pressure controllers have failed, you must use the outflow valve switch to control cabin altitude until landing.